So now in this video, we're going to start by looking at, we're using a 555 timer wired in bistable mode. That is not the important part of the circuit for today's video. So this is not connected yet to the circuit, but you can see here that we have an output that is high and an LED there. So first let's get a voltage measurement, and that will get us started on the topic we're going to look at, which is the power output of the output pin. So you can see we got 5 volts at the rail. When we come to the output, which is high now, you can see that it is 3.6 volts. And it looks like it drops, the voltage drops quite a bit with load. If I remove the resistor and just go to the output pin, so that's third pin down, trying not to short circuit anything, you can see it's about 4.5 volts. So it looks like the load drops it down a bit. But in any case, we also have a transistor over here. So let's zoom in on that right there. So it is wired almost as a switch. So we have the resistor to the positive rail, comes to the LED. Again, remember with LEDs, whenever you want them to light up, you need the long lead, the anode, towards the positive side of the power supply, and the short lead, the cathode, towards the negative side of the power supply. And there we go, it's coming to the transistor. So we have at the emitter, the negative rail, it is not on because it is not getting a signal. So we're going to take a 10 kilo ohm resistor, and we don't need much current, so a fairly high value resistor, and we're going to put it to the output of the 555 timer, and you can see the LED came on right away. And so we are using the 555 timer to control the transistor switch. It's giving a weak signal, and you can see here, if we turn the 555 timer output off, they both go off. We turn it on, they both turn on. So far it's not terribly exciting. They look pretty much the same. So let's go to the voltmeter and see what we got. So first let's measure the voltage across this load right there. So that's the load, that's the resistor and the LED. The resistor is limiting current. We can go across the resistor, it's a 1 kilo ohm resistor, and so we can expect about 1.7 milliamps of current going through the LED. So we're going to go across the, this is also a 1 kilo ohm resistor, but you can see there's 5 volts across it. So let's just measure the voltage across the resistor. You can see it's about 3.1 volts, so we can expect about 3.1 milliamps of current going through the resistor, the LED, and then collector to emitter. A little bit of current is going through this resistor. Again, it's a 10 kilo ohm resistor, so you take that voltage divided by 10,000 ohms of resistance, so probably about 0.3 milliamps of current. So in any case, as I said before, this is not terribly exciting. So let's zoom in, and these LEDs stay pretty bright even with low current. So what we're going to do, let's turn them off so we can see what's going on a little better. I'm going to move this resistor back 1 row away from the LED right there, and do the same thing with this one. Move it back 1 row, and let's slide this one over a little bit, make a little more room there, and I almost didn't want to go in there. So now I have a couple more LEDs, so I'm going to put them in series. The current's going to have to go through this LED now. Long lead the anode more towards the positive, short lead the cathode more towards the negative. That's going to apply to all of these, and do the same thing with this one. Let's scoot this one over and put this one from the resistor, long lead, short lead, to that LED. Now let's turn the output high. Now you can see quite a difference there. So as we saw, we have about 3.6 volts. Maybe it went up a little bit more because not as much current is flowing through, but we had about 3.6 volts. Each one of these LEDs blocks pretty much 2 volts, but at lower currents they block a little less. So let's see what they're actually blocking. Probably about 1.5 volts each, maybe 1.6. So we still got 3.6. We come across the 2 LEDs. You can see it's blocking about 3.4. One LED is blocking, looks like 1.7, which of course is half of 3.4, so that makes sense. And this one's blackened, 1.7. So now over here, again, we have the 5 volts because the transistor is conducting fully. It has that weak signal coming through, but it's enough. It amplifies. We have a certain amount of current, probably about 0.3 milliamps of current going from base to emitter, and it's amplifying up to probably hundreds of times the current. But of course, once it gets to whatever current this will let pass through, it will stop there. So we got 5 volts across all 3 of these that load. One LED, it's okay, it's about 1.8 volts, as is this one. So they're blocking about the same voltage, slightly more than this one because there's more current. But in any case, you can see the results. The LEDs are brighter. So 2 series LEDs, the output directly with the 5 volt power supply. We could use a higher voltage power supply and the output would be higher. It'd be closer to the rail voltage. As you raise the voltage, it also raises the output voltage. It just won't get all the way to the rail voltage. But here you can see that doesn't matter how much voltage the output loses, as long as it can pass a small but significant amount of current from base to emitter, the transistor is going to fully conduct pretty quickly. So it's a transistor switch, the 2N2222A, an NPN bipolar junction transistor. So other transistors operate in different ways, but this is the most common one, the first one you learn. So hopefully that all made sense. If you ever come across integrated circuit or other outputs and they mention if it's not powerful enough for the load, use a transistor, this is what they are talking about. You come across that all the time. It's pretty straightforward once you understand what it means to use a transistor to amplify the power of the output. The output is an on or off, and it's just not a terribly good on or off by itself a lot of times. So the transistor can provide more power than the output by itself. Thanks for watching. I will see you in the next video.